Hi, my name is Rupert Hung, and I'm one of the co-authors on the manuscript entitled Age-Dependent Prognostic Value of Exercise Capacity and the Derivation of Fitness-Associated Biologic Age. We had two main objectives for our study. First, we're interested in seeing the effects that fitness and older age had on predicting overall survival. From the literature, we know that fitness is one of the most powerful predictors of survival, but we wanted to answer whether or not the importance of fitness diminishes with older age. Our second objective was to come up with ways to promote physical activity in a population where there is a very high prevalence of sedentary behavior. We know from the literature that determining what's called biologic age from markers of lung health, such as FEV1, have been successfully used to promote smoking cessation. Because of this, we wanted to derive biologic age from fitness as a potentially very powerful tool to encourage exercise and other important lifestyle changes. In order to address these two objectives, we analyzed roughly 57,000 patients without established coronary artery disease or heart failure at baseline from the FIT project, which is a very large retrospective cohort of patients who were all clinically referred for exercise stress testing at the Henry Ford Health Systems in Detroit, Michigan between the years of 1991 and 2009. Patients were followed for roughly 10 years for all-cause mortality and 5 years for heart attacks. Hazard ratios that were associated with exercise capacity was calculated using Cox regression models with adjustment for things such as demographic and haemodynamic data, medical history, pertinent medications, and also the indication for stress testing. We further derived fitness-associated biologic age, which we defined as the chronologic age in which similar risk for mortality and also heart attacks were observed. And the methodology in which we did this is very similar to how arterial age has been derived in the literature. So there were two main results of our study. First and foremost, what we found was that higher fitness remains important for all patients regardless of their age. We observed a very strong dose-response relationship between fitness and also heart attacks and mortality. For example, each one metabolic equivalent increment in fitness was associated anywhere from a 12 to 18% lower risk for mortality depending on a patient's age. So in clinic, we're often asked by our patients, how much fitness should I have? And, based on our data, a good initial recommendation would be for patients to try to be above average for their gender and also age cohort. But ultimately, all patients should really be encouraged to be as fit as they possibly can, as is practical for kind of their lifestyle and also genetic potential. Our second main objective was to derive biologic age from fitness, and the results are available in our manuscript. However, I wanted to highlight what I found to be a very striking result, which was that within each age decile, biologic age truly varied quite markedly, up to 30 plus years, depending on how fit a person was. We believe that patients often underestimate the role that fitness plays in determining their survival, and we hope that by utilizing biologic age, patients not only have a better understanding of their exercise test results, but they also understand their fitness-mediated risk better, which we hope in turn will prompt greater compliance to exercise and also other important lifestyle changes. So to summarize, fitness remains a very important modifiable risk factor for patients of all ages, and we hope that our derivation of biologic age here can help facilitate discussions with patients regarding the importance of important lifestyle modifications. Thank you again for all of your time.